Hi, welcome back to Moose and Chemistry. This is electron configuration of nickel Ni lesson. Now nickel is the 28th element on the periodic table, so we're going to put 28 up here, and that's called our atomic number. Our atomic number represents, of course, the number of protons. So we're going to have 28 protons, and since all elements are electrically neutral, we're going to have 28 electrons. Now what about our neutrons? Well, we have to look at our AMU. Now our AMU is a combination of both protons and neutrons. So nickel's AMU is 59, right? So we're going to go AMU minus the number of protons is equal to neutrons, right? So this is going to be 59 minus 28, which will give us 31 neutrons. So we're going to put 31 up there. All right, now we're going to clean everything up here. And you might see some flickering going in the background. There's just been some sort of programming kind of conflict lately with the program I'm using, so hopefully we'll work through this. All right, now we're going to use the off-ball principle, which is the diagonal rule here. And we have to remember that S subshells can hold 2 electrons, P subshells can hold 6 electrons, D subshells can hold 10 electrons, and F subshells can hold 14 electrons. We're going to start off at the 1s, and then we're going to work our way down, okay? So this could be 1s2, then come back to the top of the slide right here, work our way down. This is going to be 2s2. Top of the slide again, this is going to be 2p6, 3s2. Come back to the top of the slide again here, 3p6, 4s2. And then we're going to go, of course, here, and then we're going to run off to go to 3D. And then notice that we're not going to use up all the electrons, so it's going to be 3D8. So 2 and 6 make 10, 2 and 6 and 2 make 20, plus 8 make 28. Now we're going to do orbital notation. Now, orbital notation is a little bit different. We're using Hund's rule. Remember that when you do Hund's rule, you have to put an up arrow in every suborbit before you start with a down arrow. So let's go ahead and clean this up a bit again and give us some clean slates here. And we're going to cross release all this right here because we don't need this anymore. All right, now we're ready to go again. Okay, so here we go. So, all right, we have 1s2, so we have an up arrow and then a down arrow. 2s2, up arrow, then down arrow. Then we have 2p6, so we have 2px, 2py, 2pz. So we go up, up, up. Then we go down, down, down. See, that way we used up those 6 electrons. 3s2, up, and then of course down. Then 3px, 3py, 3pz, 3 up, and then 3 down. So we're putting an up arrow in every suborbit before we start the down arrows. So 4s, up and down, because it's its only suborbit. Then we have 3dx squared minus y squared, 3dxy, 3dyz, 3dxe, and 3dz squared. And now we have 8 electrons. So we go 1, 2, 3, 4, and 5. So the first 5 go up, then the second 3 are going to go down. Pretty darn snarly, eh? Now, when we do noble gas notation, NGN, right? We have to find the nearest noble gas to nickel. It can't be the one after, it has to always be the one before. So the nearest noble gas to nickel on the periodic table, of course, is argon. So we're going to have AR. Now argon is going to take up all of this area right here. Okay, so here, all this right there. So that's going to leave us 4s2 and 3d8. Now, according to noble gas notation, you have to put in numeric order. So we write it as 3d8 and 4s2. You notice that's different from the electron configuration. All right, now last but not least, every element in the periodic table has a unique set of quantum numbers. The N quantum number right here is our principal quantum number. So although nickel appears to be in the 4th period, it's not. It's actually in the 3rd period because it's in the D block. So the N value for nickel will be 3. All right, and the L value, the angular momentum number, is going to be 2, because in the D block, that value is 2. Now the magnetic number, so what we have to do is we have to go through the sequence. So we start off with scandium, which is -2, right? Titanium -1, vanadium 0, chromium 1, manganese 2. Then iron's going to be -2, cobalt is going to be -1, and the nickel is going to be 0. So our magnetic number is 0. Okay, right there. Last but not least, let's find the last arrow using Hund's rule. It was going down. See that? So that means if it goes down, it's going to be 1/2 negative, because up arrows are 1/2 positive. So we're going to use this right here. So this number is going to be 1/2 negative. And that's it. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Moosing Chemistry!